Hello and welcome to Malware Academy. So in this video we're going to make our own little malware scanner. So basically this is how old virus software on your computer used to work when it scanned for viruses and malware in the files that you either downloaded or asked the application to scan for you to see if it contained malicious content. So nowadays the virus application that you have on your computer is way more advanced than what you are seeing here. They have like additional pattern recognition. Some of them even use machine learning and AI to see and look for malicious behaviors. But here we are just going to the very basic in order to teach you how this actually works from the ground up. So our virus applications today still make use of this, but they have an additional layer. But it's a good thing to learn how this actually works, and then we can build from there. So what we have here is a simple Python application where we are using the hashlib library, because what we are doing here is basically we are making a hash value of a file, and then we compare that hash value to other hash values that we know is the value of a malicious file. So let's say that we have detected a virus once, so we have seen, okay, this is actually an application containing a virus. We can make a hash of that particular file, and then whenever anybody else scan against this particular hash, if the file hasn't been changed, it will warn them saying that, hey, this particular application in its current form has previously been detected as being malicious, containing virus or malware, and then they can flag it. And that's basically what we're doing here. So we have just taken two random hashes here just to illustrate how this works. You can add any amount of hashes you want. Then we are having a calculate hash method that will simply just take in a particular file. So here we'll take a file path because we are saying down here which file to scan. Here we have just made an example file, an txt file. So this is the file we have here, nothing exciting, but it serves the purpose of illustrating this. Then we are taking this path. Then we are opening the file and we are making an active hash of this particular file and the content within it. Because the hash value that we are doing, this is using the MD5 algorithm, but the nice thing about a hash is that it is unique. We can also just see this in a second, but whenever you change a single bit in the file, anything, the hash will change entirely. So that's why you can count on when a particular file has been hashed, either for containing good content or just being the file we want. Then you can always look against that particular hash saying, okay, if this hash matches, let's say it's a good file, then you know that nobody have actually tampered with this file. So that's also how you can validate files that you download online. Typically you will see a little hash attached to it saying that this is the hash of our official file. So if you can generate the same hash after downloading the file, you know that this file has been downloaded in its clear form based on how the authors and developers wanted it to be downloaded. But let's get back to this. So here we basically calculate the hash of the particular file. Then we take that particular file hash and just look against our little array of hashes here. If the hash that we generate matches any of these, we will simply just print warning, the file has been flagged for being malicious. If it doesn't exist, we are flagging it saying, hey, this appears clean. But of course, we are having the flaw that we can only flag the files that we know of. And that's why old software, antivirus software, is way more flawed than new and updated software applications where they use other approaches than just this hashing comparison. So if we run this now, so the scan file, initiate this one, it will scan here and we'll see the file example.txt appears to be clean because we don't have the particular hash up here. But let's add that hash to it, and that's also where we can illustrate how this hashing works. So if we just print this along the way, so here we see this particular hash of the file. So if we add this to our array up here, now we have this particular hash in here, and if we run the application again, it should say that warning, this file appears to be malicious because it is in the array of malicious hashes that we have. And here we see warning, file example.txt is flagged as malicious. And now let's see what will happen if we change just a single thing in this file. So let's just say that we remove the I, and then we go back here, and now we have saved the hash so we can compare them. Now the file is clear again, and as you see, the hash value has changed entirely. It's not just a single value that got changed because we moved a single value, like the entire value is changed. And that's the power of using hashes in order to check against malicious files when you know which files has malicious software in it, but also the other way around when you want to ensure that what you have downloaded is actually the right stuff and that nobody has tampered with it in between. Then you can also use these hashes to see that the file is exactly the one that the developers put online. So this is a simple way that you in Python can make a malware virus scanner using the basic approach, and then from here of course you can build on top of this and adding even a more sophisticated features. I hope you liked the video. Remember to subscribe, and then I will see you next time here on Venslove Academy.